These are tests conducted at the China Lake Naval Research Center. This fire involves fuel without Viscon. This one is the same amount of jet fuel with Viscon added. With Viscon, there is a more complete combustion, resulting in far less smoke and lower combustion temperatures. The base component is a high molecular weight, non-toxic, pure hydrocarbon polymer. Viscon is safe to use, safe to store, and safe for our environment. Also, it is not miscible in water and will not contaminate our groundwater. A study released by the Clean Air Task Force concluded that the particulate matter from diesel exhaust causes a myriad of serious health issues. Our technology significantly contributes in combating this looming crisis. In its official report, the Office of Environmental Health Hazard Assessment cited that, and I quote, "The use of Viscon diesel fuel may reduce morbidity and mortality due to pulmonary diseases, including lung cancer in adults and allergic asthma in children, caused by substances in particles contained in diesel exhaust." The science behind Viscon is proven. California Air Resources Board, through its stringent lab testing protocol, verified our technology to reduce particulate matter emissions by more than 25%. In idle mode of the 8-mode test under CARB's protocol, particulate emissions were reduced by 63%. No other additive has come close to this level of effectiveness. This test is especially significant in light of the fact that more than half of the states in the U.S. have already adopted restrictions on idling emissions. The state of Texas, along with the U.S. EPA, approved our additive as an emission control strategy for reducing nitrogen oxide in diesel and biodiesel. The uniqueness of Viscon is its ability to improve the quality of air and fuel mixture. The treated fuel becomes highly viscous when injected into the cylinder of a diesel engine. It does this by changing the physical behavior of diesel fuel, in contrast to changes in chemistry common to all other fuel technologies. Let's take a look at what happens in the combustion chamber without and with Viscon added to the fuel. All liquid sprays have a range of droplet sizes in their pattern. This phenomenon is increased when diesel fuel is injected into a cylinder. Droplets grow in size and lose forward momentum as the leading edge of the spray encounters high pressure, and follow-on droplets collide and coalesce. The raw fuel contains a mass of superfine droplets that combust in a cloud. They simply vaporize rather than burn diffusively from their surface like a normal liquid droplet. In addition, large droplets burn partially, causing the exhaust heavy in particulate matter and harmful gases. Blending Viscon with diesel fuel changes its spray development. Superfine droplets or mist don't form, and the large droplets formed by collision are reduced. Note that the overall average droplet diameter is smaller and more uniform in size. They also achieve a greater momentum to penetrate the high-pressure gas in the chamber. The result is a more uniform blend of fuel and air prior to combustion, causing a more complete burn. As the superfine droplets are virtually eliminated from a liquid spray, the heat release rate is also reduced. This greatly reduces emissions of the particulate matter and greenhouse gases. Let's compare the combustion process of the raw diesel with the Viscon-treated fuel. The traditional diesel has a range of droplet sizes in the spray pattern. They vary from superfine, vapor-like, to large collision-caused droplets. Blending Viscon with the fuel reduces an overall size of the droplets and eliminates virtually all superfine droplets. When the raw fuel combusts, a mass of superfine droplets ignites explosively like a vapor cloud, releasing the excessive rate of heat. This contributes directly to the creation of nitrogen oxide. The unburned portion of the large droplets becomes the particulate matter which is being emitted into the air. By reducing the growth of large droplets and making the fuel vapor a more uniform blend, Viscon makes the fuel combust more evenly and burn cleanly. Tests conducted at Southwest Research Institute have shown engine horsepower and torque improvement by as much as 13%. Nordic Industries received a permit to operate for their rock crusher from the Placer Air District as a result of Viscon's impact on its emissions. This led to implementing Viscon fleet-wide. In the Placer Hills Joint High School District, using Viscon in school buses has resulted in exhaust smoke reductions ranging from 45 to 96%. The Kern County Superintendent of Schools implemented Viscon throughout its bus system, based upon an improved fuel consumption and a 43% reduction in exhaust smoke. In Chile, Suez Energy's power plant conducted emission and fuel consumption tests on a 2,500 horsepower Sulzer engine burning heavy fuel oil. With the reduction in fuel oil consumption, the plant is able to reduce its emissions needed to meet governmental requirements and have net reductions in expenses. The Essar Group is a multinational conglomerate with operations in more than 25 countries across 5 continents. Essar conducted its own testing and has integrated the product in their construction, transportation, and mining operations in India. Viscon's unique value as a fuel blending component goes beyond emissions reductions. With diesel prices hovering at all-time high levels and with no relief in sight, a small or medium-sized company could easily save hundreds of thousands of dollars a year in fuel costs. For larger companies, the savings could be in the millions. Ken Small Industries, an oil services construction company, conducted their own year-long study for on- and off-road equipment. The reduction in fuel consumption supported KSI's decision to treat all their diesel fuel with Viscon. The corporate headquarters and main production facility is located in Bakersfield, California. Each day, the facility can produce enough additive to treat more than 27 million gallons of diesel fuel, fuel oil, or gasoline. To date, billions of gallons of fuel have been treated with Viscon. To accommodate customers of all needs and sizes, we offer a variety of container options for shipping. These include 8,000-gallon tanker trucks, 6,000-gallon ISO tanks, 55-gallon drums, and 5-gallon pails for ground transportation direct to the customer. There are many strategic storage options, each specifically designed for the site infrastructure in place to accommodate the blending of Viscon with diesel fuel. At the refinery rack, it can be metered directly with the diesel as it is pumped to the tanker trucks for delivery. Other sites may require steel tanks with electrical metering devices where Viscon can be blended into a variety of fuel systems. They can also be mounted directly to wet hose fuel trucks that service on-site equipment. They can be installed directly to such equipment as generators, fueling depots for buses, and stationary fuel pumps. Today, across the globe, diesel engines for mining equipment, railroads, construction, agriculture, garbage trucks, seaport cranes, oil drilling rigs, marine fueling depots, and school buses use Viscon. The use is not limited to diesel fuel. Fuel oil applications in power plants and ship engines are being used in a wide variety of regions in order to meet their fiscal and ecological goals. Whenever there is a need for emissions reductions, Viscon can easily become the cost-effective solution. While others look to the future in hopes of finding ways to solve air quality problems, Viscon is the answer for today.